My name is Dan Duperron. I'm a senior technical marketing engineer with Hammerspace. Been with the company about a year and a half now, and I'm extremely excited to come here to Munich and speak with you today about what we do. First time to Munich, and I wish I could stay longer. It seems like a really, really functional, beautiful city. So first of all, I'm sure some of you are familiar with Hammerspace. How many of you, show of hands, have had a briefing from Hammerspace before, have had some personal interaction? Okay, great. So I could pick one of you to give the presentation then, right? No? All right, and how many of you know nothing about Hammerspace and haven't really known about us? Okay, at least one. So I've got something for everyone. Don't worry, I won't assume any knowledge here. Hammerspace is software. We refer to it as a data platform. It is not a storage device or a storage platform, although it can store data. It does a lot of things. And one thing that makes it particularly relevant is it solves some problems that enterprises who are trying to initiate AI projects are running into with their data and their storage. So I'll try to highlight that as I go through and tell you what we do. The company is a startup. We've been around since about 2018, so we're not brand new. We've been working on this one product the whole time, and even some of the software legacy goes back a little bit before that. Growing very rapidly. A year and a half ago when I joined, I think we had somewhere around 75 people, and I think it's more than 3 times that now. We have some customers who highly value what we do, and we have lots of partners as well. Some name brands you see up there, people that we're very happy to support with various initiatives. And the industry seems to like us, which is always good. I've worked for companies where that wasn't always the case. As far as the funny name, for those of you who might be new or don't know what a Hammerspace is, if you've ever watched an old American cartoon where a character just reaches behind them and pulls out something huge, usually a big hammer to smash another character with, the hammer comes out of nowhere. That's the Hammerspace where they store that. And if you play video games, that's where all your stuff lives. You know, you're running around with 400 pounds of treasure and weapons. That's all in your Hammerspace. And we do the same thing for data. We make it available anywhere you need it, whenever you need it, at high speed, seemingly out of nowhere. And it's a pretty catchy name. And we can do various things with this, including making data available with super high performance. We eliminate storage silos, bring all your data together to make it easier to access and manage. And we'll talk about some of these things specifically later on. We're fortunate, you know, when you're a company who's not chasing trends, but someone where trends seem to be coming to you, that's always a good place to be. And that's how we feel our place is today. Got a number of things happening. Some that we set out to solve and some that sort of happened. AI is the big thing. Everyone's trying to do something with AI. AI usually requires tons of unstructured data. And this data has typically been linked to applications in different silos. You know, one application, one pool of data. AI just completely destroys that because it wants access to all types of data from all different types of applications. So that creates challenges. These data sets are large and they're spread around different geographic locations, different storage silos, different applications, different formats. And of course, people and applications live everywhere as well. Different sites, different clouds. So the fact that we created a company to better manage unstructured data at scale, break down storage silos, very fortuitous because these are exactly the sorts of things that are holding up AI projects and making them more difficult to implement. If you remember 3 things about what Hammerspace does, these are a good 3 to remember. We help consolidate data, bring it all together under one global parallel file system. Once it's in that file system, we help orchestrate that data wherever it needs to go. If it needs to go to GPU servers in the cloud, great. If it needs to go to another site, wonderful, we can do that. And we also offer a high-performance parallel file system and some other tricks and methods I'll show you to make data available with super high performance, all without having to install any client software. So this is all standards-based. I'll say that again. You don't need any software on the client to access Hammerspace, and you don't need any software on your storage system for it to become part of a Hammerspace.
Isn't there something missing from that picture in that even with AI, you want to know something about the quality of service of that data, something of the quality of that data, and all data is not the same. Some data is of higher quality than others. If you lose that, then you lose some of the value of that data.
Right. So you'll want to highlight when I talk about metadata. And because Hammerspace can work with file system metadata, obviously, as well as custom metadata that can be brought in from other tools and methods. So you could, for example, tag or label data, track it through a workflow, or note its quality.
So you use Hammerspace as a cache in front of an operational transaction processing database, for instance?
You certainly could, yes.
Yeah. Do people do that?
In the sense of driving a workflow, yeah. So storing specific data into metadata attributes to marshal files through a workflow, yes. So I'll come back to all that when I talk about metadata, which is toward the end. So you'll need to stick around.
So shut me up for one.
No. Thanks for breaking the ice. Please, any questions, keep them coming at me, because I do not have 90 minutes worth of slides for you. I'm sorry to disappoint you.
You don't.
No.
We'll ask you enough questions for the 90 minutes.
I hope so.
Necessary.
I hope so.
Careful what you ask for.
We'll have fun no matter what. So the root of the problem here is that you have storage silos. Just because of the way IT works and has worked historically, you have different silos of storage and data and metadata that goes with that data. And every time you implement a storage system, it has a file system kind of trapped inside of it. And that's the face that it presents to the world. You access data, applications access data through that file system. And that file system has certain metadata, and that's what you see when you do an ls on a directory, et cetera. But that's trapped inside the storage system. So any enterprise that's been around for more than about 3 days runs out of capacity, needs to buy another storage system, or has a special use case that requires high performance. AI is another good example of that. Has to buy another storage system. That creates another silo of storage with another pool of data and metadata that are trapped. Now, I used to work for Citibank, so I'm familiar with this problem, where you have dozens or hundreds of storage pools for different reasons, different applications, and they span file and object and cloud. And this is sort of barely manageable for a good storage guy. It's sort of the way things are today. And the way you manage all these different storage silos and the data you have across these storage silos is you typically implement a bunch of point solutions that do various functions, whether it's site-to-site replication, bridging to the cloud with a gateway, snapshots, DR, data protection, all those sorts of things are applications you layer on top of this siloed environment to try to get a handle on it and do what you need. And this can be really ugly, as any IT or storage guy can tell you. It makes it difficult for people and applications to access data. So when an enterprise contemplates layering an AI project on top of this that needs access to some of this data and some of that data and a lot of this data, it can become a catalyst to look for better solutions. Because everyone recognizes today this is already broken. This was broken before AI came on the scene. AI simply highlights how broken it is. And we'd like to help fix it. Foundational concept of Hammerspace here that is really simple to draw on a whiteboard, and turns out it's really hard to implement. We looked at this and said, well, the problem here is the storage silos. That's a fundamental problem. The file system's trapped inside the storage system. But if we pull the file system out of the storage system, put it close to the applications and users, so that it's no longer trapped and it encompasses all the storage and all the data, then there are lots of good things we can do.
Isn't that just what a DBMS does with data?
You must be a database guy. Huh? You must be a database guy. Okay. That's an interesting way to look at it. I hadn't thought of that. But yeah, you're abstracting the data that's in your tables and rows and columns below.
Well, the user should not worry about the data. They should be looking just at the logical data, accessing like that.
That's right, the metadata.
Yeah.
So just like on your laptop, you don't worry about what chip on the SSD your file is stored on. You just experience it through a file system, right? So layers of abstraction can be extremely helpful. We pull that file system out and put it on top. And once we do that, that means lots of other functions can be hidden beneath that and accomplished without users and applications seeing them, like data orchestration. If you keep the file system presentation the same and it's abstracted, we can do all sorts of things below that to move data around, and users and applications never have to know about it. Whereas before, if you went from one storage system to another,
could
things
you
would change.
precise what do you mean by objective?
I will spend quite a bit of time talking about objectives a little bit later. Thank you. And if I miss one of your questions at that point, let me know. Okay, so remember that. We pull the file system up out of the storage. And then if you have a file system, you have to get awareness of your data into it. And we do this with a process known as assimilation. Assimilation is a metadata process. So you think about the old days, you buy a new storage system, you have to migrate all your data into it. That may take days, it might take weeks, it might take months. It involves some downtime. It can be pretty ugly. And that's commonplace today. I have talked to organizations in a previous life of mine who were constantly doing data migrations because it would take them 2.5 years to migrate petabytes of data to the new platform, and by then they were planning the one after that and had to start that migration. Assimilating metadata, in contrast, is very rapid because the metadata is very small. So assimilation pulls the metadata out of each storage system, brings it into a central database, and once we've done that, we can start presenting files and objects out from Hammerspace to users and applications, even while this assimilation is still going on.
Well, one issue is there's two kinds of metadata. There's the metadata that describes the storage, and there's the metadata that describes what the data actually needs. And what often goes wrong, particularly in file storage systems, is that people make assumptions about what the data needs and turn out to be wrong. In a database, in theory, but it's not happening. People actually sort it out what the data needs before they build a database, sometimes.
Life can be easier with databases, right? Unstructured data is ugly that way. And you've touched on something about metadata that's important. I'll make a distinction between file system metadata and content metadata. Content metadata being things like, the MIME type of the file, what's inside of it, how many frames are in that video, all sorts of things like that are content metadata. The metadata we're harvesting as part of the assimilation is the file system metadata, including things like access rights, what the path names are, where the files live, permissions, that sort of stuff. We do deal with content metadata to some degree, and I'll talk about that a little bit later.
The name is metadata, isn't it? The name of the data, the name of the file. And that's often
Correct.
wrong. Yeah. People assume that because it's called thread, it is that sort of, it is all thread. It may not be.
That's right. That's right. And it is possible to use tools against a Hammerspace global file system to straighten some of those things out. And that's common in AI. You've got data that's scattered everywhere. You want to pull some of it together. You need to find the right stuff. You need to validate that it is what you think it is before you can train, a large language model or whatever on it.
Or you could not bother, just shove the stuff in anyway, hope something comes up with it.
Or if you're not interested in quality, you can do that. That's right.
Describes most people.
It does. It's expedient, right? It's faster to do that.
And all you want to do is to get the answer out that backs up what you're going to do anyway. So you just run the model again and again, and it gives you the answer you want.
Unfortunately, that can be an approach. So again, metadata assimilation happens. The data remains in place on the existing storage. So we haven't forced a migration of the data into a new thing. We've just created this global parallel file system by harvesting the metadata. And then any new data you store into Hammerspace gets stored on these storage platforms below. And that's all controlled with objectives.
Metadata are just the pointers to the data.
Oh, it's a lot more than that. It is the pointers to the data.
At first sight, it looks like this way.
Right.
Do you need a replication of the registry of these pointers, not to be the spot of the solution?
We do, and that's all protected, and I'll show you how that's protected when we get to the physical architecture.
And are you happy for people to use that then at the bottom with point solutions at the same time as Hammerspace is managing as a Hammerspace environment?
So that's a good question, which I'll repeat. The question is, can you access these file systems after implementing Hammerspace sort of from the side? Can you also use them from elsewhere? And the answer is usually no. System is designed so that once you assimilate the storage, Hammerspace owns it. And if you change things down here that we don't know about, that can be a problem.
So how do you enforce that?
That's enforced basically by pointing users and applications to Hammerspace shares instead of shares down here.
Okay, so it's down to the professionalism of the
Correct.
IT group. If they give somebody extra access, they're important to be access stuff fast.
Right.
Best things up.
That's right. And there are limited situations where that's okay. You know, if this data is read-only, or you know, if you have some occasional use case, you can make sure no one's accessing that system, do whatever you need to do, and then you can redo the assimilation. But generally speaking, we want to own the data.
That's a bad practice, because if you allow that, sooner or later somebody will update access.
Right. But I also don't like to say no, so there are cases where the answer is yes. And then, of course, the data orchestration can happen under the covers, as I've said. Now, just to emphasize what a user or an application sees, they see their files in a share or in a S3 bucket where they left them just like normal. It's just that they're viewing that now as presented by Hammerspace. Administrators, they know what's going on. Things change for them, but it's in a good way. Their storage is consolidated. They can see all their data in one place. They can set policies to manage that data at a global level, even across sites and clouds. So data protection can be handled in a uniform way. Things like snapshots, data services like Worm, et cetera. And they get a global view of all their data. So a huge benefit in administrative time reduction. You know, if they manage 3 storage platforms with 3 sets of snapshot tools now, that becomes one data platform with one snapshot tool that works across all of them. You guys over here on this side of the room, I'm gonna need some questions, or I'm gonna have to bug you more, because they're all coming from over there. But let's talk about how this is actually done. This is what we call a marketecture diagram, in that it doesn't look anything like the real architecture diagram, but it sort of describes and categorizes what we do. On top, users and applications. They can be in the cloud, they could be at multiple sites. They experience Hammerspace as a standard presentation, an NFS export, you know, an SMB export, an S3 bucket, a CSI driver for Kubernetes, and something I'll spend quite a bit of time talking about, which is parallel NFS, which is an option. So again, all standards based. You notice here there's no little special client up here on these systems. And the data access layer is how they experience that parallel global file system that spans all the storage. And then, of course, between that file system and the actual storage repositories, you have this rich set of data services that does all the things that an enterprise storage guy would expect, as well as some fancy data orchestration to manage things beneath the covers. And again, that's all transparent because it's behind the file system. Hopefully you understand that with assimilation, this means you don't have to buy new storage to implement Hammerspace necessarily. It is often purchased from the storage budget and purchased when there is a new storage requirement, but it's not a requirement of ours. You can do it, you can implement it just for the global file system if you like.
If some of the files are on a slow storage, which maybe had a quick use, do Does Hammerspace caching or something bring everything up to the same performance level, or will you have areas of your Hammerspace environment that are slow because the underlying storage is slow?
It will be slow because the underlying storage is slow. But if you need it to be fast on Tuesday, you can create an objective that will put it on storage somewhere with minimum performance you specify on Tuesday.
Then put it back again.
Exactly.
Okay, so you're almost abstracting the underlying part. This is the
Right.
one.
And you get the best of both worlds in that your slower storage is probably less expensive, and you can't afford to put everything on your super fast storage. But with data orchestration and objectives, when a data set needs to be on fast storage, it can be there.
So you have a pool of fast storage in your Hammerspace system, which is available to any application that needs it on.
Yes.
Or year-end or something.
That's correct. You certainly could. Now we get down to installation. We're all technical guys, so what do you actually do with the keyboard? How do you install this? Hammerspace comes as just an ISO file. It's got everything you need. It's Linux operating system. It's got all the dependencies. It has our software, all the packages needed. You run that on bare metal. You can run it on a virtual machine instance. You can run it on a cloud VM, any server that can run Linux, basically. There are, of course, minimum hardware requirements that depend on what you're doing with the system. But that aside, you can run it on basically any hardware. There are two node types in Hammerspace. There are the metadata nodes that are called anvils. Hammer and anvil, you got it. And then there are data services nodes we call DSX nodes. The anvil nodes handle all metadata operations. That's our metadata control plane. And you will deploy at least 2 of those in production, and optionally 3. So that is how you protect. It's one of the ways the metadata is protected, is the anvils are replicated in the cluster. The DSX nodes are responsible, like I said, for data movement. They also present the Hammerspace file system exports and shares to the world, S3 buckets, whatever. And you can scale those out. The official limit is 60 today. We know we can go way beyond that. That's just the official tested limit. So these can essentially be scaled out as high as you want, and the servers can be as big and beefy as you want. So there's really almost no limit to the amount of data services and data movement that we can handle under the covers.
So the metadata controller is in the parallel file system usually the critical piece because nothing will work without it. I assume you have some HA clustering things in there. Do I have to configure something myself, or is it just in the ISO I install it and everything will find its partner and everything is fine?
It is the second case.
Okay.
You just install the ISO. You'll have to assign IP addresses to the various nodes. The anvils will form a cluster on their own and handle replicating all the critical information between them. So yeah, you don't have to worry as an administrator about installing an operating system and setting up clustering and then installing Hammerspace. It's just all at once. We try to keep it easy.
How do people do this? It seems to me to be common sense to design your system with Hammerspace from the first, because it's just a rational way to access different data sets.
Right.
Do people start off with Hammerspace, or do they start off with chaos and then put Hammerspace in place and they realize that chaos doesn't work well?
Usually they start from chaos. And those are our best customers because once we solve the chaos, they're very, very happy. I have talked to a few at trade shows, talked to some companies that say, wow, we don't need this right now, but I can see this problem coming. So I want to do something now. But that's very rare. Usually people are in pain and they're looking for a way to solve that.
But that means that some of your potential customers may have gone out of business before you get a chance to sell them.
Sure. But fortunately, we haven't been installed in every organization on the planet, so we have a few targets left. Yes, sir.
the storage providers, companies like NetApp, Pure Storage, yeah, they have similar functions in their storage OSs. So how isn't it obvious that their functions are interfering with your functions?
Well,
maybe things like replication.
Right, so that is a very real possibility, right? So the question is about, if you have a storage system that has functionality that overlaps Hammerspace, which most of them will, how do you keep them from conflicting? And the answer is pretty simple, is you don't use that functionality anymore in the underlying storage system. Because we've put that up at a higher layer, you can do it in Hammerspace, and then you don't have to do it any longer with that, within that vendor silo, that vendor walled garden. Realistically, if we walk into an organization, start talking to them, and they have all their storage from one vendor, and they're very happy, and they have all the functionality they need, then they have no need for Hammerspace. We have nothing to sell them. But that's basically not true anywhere. So
I do have one question, though. The typical case is what you described, very heterogeneous environments with lots of different storage arrays, different generations. But how do you handle, let's say, a case when the vendors are kind of getting to the point, the customers are getting to the point where they're going to upgrade their storage? Are you recommending them specific, platforms, or what is the kind of the upgrade path when I'm a Hammerspace customer?
You guys have been holding back. This is a great question. So customers have options, and that's one of the great things about Hammerspace is that customers maintain options. They can continue buying what they have. Maybe they just need capacity. They can add capacity to those arrays they already have. Or if they want to buy net new storage, it can also be very simple. They can buy a white box, say NVMe storage server, put Linux on it, and put it behind Hammerspace. So one of the sneaky things we're doing here, storage becomes a commodity. It's not something you have to necessarily overpay for to get functionality that you may or may not need. It can be very, very basic, and Hammerspace provides all these higher layer functions. So while we don't necessarily recommend, because we don't really have any, we don't sell the storage, we don't have any skin in the game, customers can simplify their storage purchases that way. Yes, sir.
What's the block storage systems, fiber channels, on and so on? That's also covered here, or because I matched the LANs directly, I send it to my Windows servers?
So block storage fits in. I'm not going to go through every aspect today of the DSX nodes. I don't have a slide on this one, but you can attach block storage to a DSX node and bring it into the Hammerspace system that way. If you wanted to, like I said, these could be those white box Linux servers that you've got some NVMe drives in and add them in the same way. So we can accommodate block storage in that way. Okay.
But I can't use block storage on top of Hammerspace from the application layer.
Correct. Right. That's right. We don't present fiber channel LUNs out the front or anything like that. It's all file storage and object out the front. The object storage is a little bit new, so I keep having to stop myself and add object. So that's the basic overview of all the Hammerspace capabilities. I want to dig in now to a few that are of particular interest for high performance use cases, like the AI stuff. That's all the rage right now. We've touched on this a little bit. Vendors have different strategies. Some benefit them, some benefit the customers, some they do because they're easy. There's the walled garden approach. Vendor says, buy my shiny storage thing. It will do everything you need. Put all your data into it. You never have to worry about anything again. I'll solve all your problems. And that can be a true statement right now. But over time, things change, and you have to buy the next new shiny thing, migrate all your data into that. And if that walled garden has everything you need, has all the services you need, it can be a very nice, unified way to do things. But that's rarely the case. Hammerspace is more of an open approach. We want to break down storage silos, not create a new one to sell you that you then put your data in. So To do that and to preserve that flexibility and openness requires interacting with standards. Not just using the standards as they exist, because I think everyone knows, SMB isn't perfect, NFS isn't perfect, S3 isn't perfect. And the way you impact standards is by working with the standards bodies. This slide's a little bit busy, but this is a timeline of some of the key enhancements that we have created and submitted into the standards process. Things like NFS 4.2, that RFC for the IETF was written by a Hammerspace engineer. Our head of performance engineering, 𝗔𝗰𝗵𝗲𝗶𝗀𝗵, he was one of the co-writers of the NFS v3 RFC years back. So we have numerous people working on the standards themselves to improve them. But if you think about what a standard is, it's a sheet of paper with some words on it. To implement the standard, you need somebody to write some code. So we also employ a number of Linux kernel maintainers. Now let's see, when's the last time you heard somebody talk about Solaris or IRIX or HPUX? Right. What is that? What is that junk, right? Probably 20 years. Linux won the data center operating system wars a long time ago. And this is wonderful. That means by having people build all these features that we get into the standards into Linux, you don't need a client to access any of them. They're available to anybody because they're in the standards, and then we build them into Linux. Our CTO, for example, 𝗔𝗰𝗵𝗲𝗶𝗀𝗏 is he's the NFS kernel maintainer for Linux. So we do an enhancement to NFS, he builds it into Linux, it goes upstream. We don't hold things back, so we don't have proprietary patches and things like that where we do special tricks. We contribute things back to the community. So it's entirely a standards-based strategy.
Just one question for understanding. Did you say that you don't support object storage?
We do support object. Yep.
That's why you mentioned S3.
Correct. You can have object storage as one of the storage platforms that Hammerspace uses. We can also present buckets out the front so that you can interact that way. And you can store a file in with NFS, and you can access that file via S3. You can store an object with S3. You can access that object with SMB as a file. So any of the data in the system, regardless of how it came in, can be accessed via any of the protocols.
That's how it should be.
That's right. It's a universal translation layer, essentially. It's how it should be, but it's like most things. It's not trivial to do it well. So parallel NFS. I'm guessing based on just the hair color of many of you that you've been around a while, like I have.
Hey, speak for yourself. Oh, okay, that's not going to be a good write-up now.
At least you're all awake.
You're going to be trashed.
And some of you with hair color like mine probably remember pNFS came out. And there was kind of a lot of noise about it because everyone had high hopes for it. And in a word, it didn't live up to those high hopes. It didn't perform as expected. There was a lot of chatter on the networks when it was used. It didn't work so well. Most people at that point sort of wrote it off and forgot about it. We've spent about a decade improving it, working on NFS and parallel NFS to make it work. And the whole objective here, if you look at this diagram, you say, okay, I've got a client, I've got some storage, I have a metadata server. This could be any high-performance parallel file system on the planet, right? Could be looking at Lustre or storage scale or BGFS. They all separate metadata from data for performance reasons. We wanted to build an open standards-based high-performance parallel file system so that these very specialized file systems just weren't needed anymore because they're hard to use. And now we bring this back to AI. Enterprise AI projects looking at high-performance storage are often also trying to figure out what file system should I use to get the performance, and they're put off by file systems like Lustre that, to be fair, they grew out of academic and research environments, which are very different from a corporate enterprise in terms of IT management. So what we've done is,
when you were building this pNFS, didn't somebody come up with a competitive competition that while you were working on yours, or did they just use the specialized file systems?
well, that I'm aware of, there's no other standards-based parallel, high-performance parallel file system out there.
I wonder why nobody came up with one while for its hard, I suppose.
Well, the easy path was to create one that used your own protocols and thus needed a client agent of some sort to run it. And you just said, hey, if you want to use my high-performance file system, the clients that need to access it, you need to install my software, and then everything's good.
Well,
Right.
there is, or there was a parallel Samba from 𝗔𝗰𝗶𝗶𝗶𝗀𝗏, but it's not really standards-based.
Right.
It's also some proprietary extension to the Samba things.
Exactly. This is just Linux, because we built it all into Linux. So, like I said, here's the architecture. You have storage, you have clients, you have the metadata servers, which are our anvils. When a client needs to access the storage, it talks to the metadata servers. If you want to really get in deep, you can read all the RFCs. The metadata server will handle layout to the client. The layout describes where is the storage, how do I access it, what are my credentials. And then the client goes direct to the storage. And there could be multiple parallel paths here. That's how you get high performance. So this is great. And part of what was wrong with the original parallel NFS spec was there were three layouts, types, block, file, and object. And the file layout wasn't great. The standard left the door open for people to create new layout types in the future. So in 2018, we created the flexible files layout. And that's what we use. So this layout type is the flexible files layout. And the flexible files layout defines the path here, the data path, using NFS v3. NFS v3, as you all know, is stateless. So you don't have overhead setting up and breaking down sessions or anything like that. So for data transfer, it's very fast. And that's one of the differences with flexible files layout versus the previous files layout. The fact that this is NFS v3 is also really convenient because every network storage system on the planet supports NFS v3 if it's a file storage system, right? It's kind of the lowest common denominator. That means any NFS v3 system can be used to create this high-performance parallel file system. There are a couple things here to remember that are important because we are seeing competitors now sort of use some of our language and try to get in on some of this parallel NFS action. NFS v4.2 is important. Remember, this is something that 4.2 is something we invented and contributed. 4.2 defines some optional operations on top of NFS 4.1. And several of those create a telemetry feedback loop. Because in this architecture, the client's talking to storage. If the client's having a bad experience with the storage, can't get there, performance is bad, before 4.2, it had no way to tell the metadata server about that. With 4.2, the client can now tell the metadata server, I can't reach this storage device you've handed me in a layout, or my performance with this storage over here is good or bad. Now that the metadata server has that information, it can not only consolidate it and report on it, but it can act on it. So if a certain client can't reach a certain storage server, the metadata server in the next layout can say, well, okay, use this storage server instead. So it adds a lot of resiliency to the system. So NFS 4.2 and the flexible files layout are both important.
You use OpenTelemetry, or is that a stupid question?
Sorry, please say that again.
Do you use the OpenTelemetry standards, or is that a stupid question?
I don't think it's a stupid question, because I don't know the answer. I guess it's open in the sense that it's defined in an RFC and it's a standard, but I don't know if it's based on any other standards.
Yeah, well, OpenTelemetry, yes, I'm not sure I know enough about it to actually contribute, but it's a way of people coming to actually move telemetry information around the place.
I see. No, it makes sense, and I don't know if it's related.
Okay.
when you look at performance for typical scale-out and disaggregated NAS systems, as you add storage, their performance does not increase in a linear fashion. That is one of the downfalls. It's just, you may be able to scale them very large, but just because you scale the capacity 10x doesn't mean you get 10x the performance. The marketing term we use for this parallel NFS high-performance file system is hyperscale NAS, because it sounds sexier than parallel NFS. And it does experience linear performance increase as you add storage. So if you double the storage, you have double the potential performance in the system. This is what we thought was going to happen, but being a small company, we couldn't test this at a large scale to find out. We had to find a friend to do that for us. And that friend turned out to be Meta. They were searching for a solution for large language model training. Now, if you know about hyperscalers, they don't buy hardware like you and I do. Right? They tell manufacturers what to build, and then they buy that. So they have open compute platform storage servers. They're all running Linux. They had 42 petabytes of data on those storage servers. This is because they had tried, hyperscalers also tend not to buy software. They tend to just write it themselves. Because A, the requirements are different, and B, they have a lot of money, why not do it yourself? They had tried to create a high-performance parallel file system. And they got into it and realized how complicated it was. And they started looking at alternatives. They looked at everybody, but they didn't want, they ideally didn't want custom hardware, special hardware, and they wanted it to just run on Linux. They didn't want to have to install a client. Because they have their own build of Linux, they've got it instrumented, they know what it is, and they really don't want to deviate from it. So our standards-based approach was very attractive. So they built this out. They deployed a trio of metadata servers, Anvils in a cluster. They used assimilation to bring this 42 petabytes of data into Hammerspace, leaving it in place on the storage. And then they presented that to 3,000 GPU servers and went to town training their large language model. And they absolutely love it. Most recently, they decided they don't have enough GPUs, they have to rent some from Oracle. So they're doing training in the Oracle Cloud. So they put up Hammerspace in the Oracle Cloud, bridged their on-prem data with that instance in the Oracle Cloud, and now they're doing training using cloud GPUs as well, all with Hammerspace. So we have evidence that we couldn't produce because we don't have enough money, that this parallel NFS architecture does experience linear performance scaling, and it really does work at scale. And you don't have to be Meta to get value from it, but we figure if we build for the biggest, then everybody else is kind of taken care of. So that's the parallel NFS piece that you'll see us refer to as hyperscale NAS in our marketing literature. And unless there are questions, that's all I'm going to say about that. But thinking.
Anyone? I mean, it's got AI in the title. There's no questions. That's surprising.
Well, because AI is pure magic itself. It's just,
Well,
it's just all fantasy.
So you also have collaboration with NVIDIA. Well, NVIDIA is trying to set standards for storage now.
they are. NVIDIA is doing lots of things. NVIDIA has lots of friends. We are very friendly with NVIDIA for lots of reasons. You know, they carry a lot of weight in the AI world. We are compatible with GPU Direct, for example, which I didn't mention. So we can integrate in, you know, that type of storage environment. And we try to stay really close and friendly with NVIDIA for those reasons. But so yeah, we do have a relationship there on multiple levels. Yes, sir.
Question from management of the storage performance, and when you are on the Hammerspace layer, do you also do quality of service for specific, or is this job all still done by the storage system administrator that he says, okay, here I have storage layer, high performance storage layer, mid performance? Or can you handle this from the Hammerspace metadata?
Right. Hammerspace will handle that once it's implemented. And when I talk about, in just a moment, we'll talk about a little bit about how that happens, how Hammerspace knows what the performance of the storage is, how Hammerspace knows what the availability level of the storage is, and then how you can manage data up and down.
But when I want to put on my physical storage 3 different performance layers, I have to configure this on the physical storage system.
Oh, I see.
And also the management, when you
Right.
say NetApp, snapshot, ransomware protection, and so on, all these native features of the storage system. So
Right.
is this still necessary that the storage admin does this basic storage system tasks on this level?
They can if they choose to. So if they like that feature, where there's some sort of internal tiering within a system, for example, they can continue to use that. We can also do that as long as the storage volumes are separate. So if you have a high performance storage volume, a mid performance storage volume, a lower performance storage volume, if they're exposed to Hammerspace, we can manage that.
The way to one storage system, you can put this quality on, or you know which quality it has, and so you can distribute the workloads.
Correct, yes. But like I said, if it's something that's transparent to the file system, it's in the storage system, and you want to continue using it, you can do that.
Is Hammerspace policy-based? So I can sit there and say, I want to have high, medium, and low storage things for these things, and Hammerspace will work out what makes sense to be those categories?
Yes, so my final section of this presentation is on data orchestration and objectives. And my objective there is to blow your mind with the ability to manage data. So we'll talk about that in a little bit. Sorry? Tequila. Yeah, tequila has some negative effects, though. Okay. Let's talk about another, and I don't have a clock in front of me. Time check, please. How are we doing?
We are doing, 1 second, I've got my countdown timer somewhere. 39 minutes, 18 seconds.
Excellent. We're in good time. Thank you.
18 seconds of question.
That's right. So another performance-related aspect of Hammerspace we've started talking about fairly recently is called Tier 0. You think about storage, Tier 1 storage is typically how you would refer to your fastest storage. So this is Tier 0, meaning it's faster. You see how that works? So let me describe why this is and what it is. Now that you understand a bit about Hammerspace and how storage is consolidated and managed under it, I think you'll understand what we do with Tier 0. Here, the marketing is that Tier 0 is unlocking a new tier of high-performance shared storage, which should raise all sorts of questions in your mind, like where did this come from, how are you doing this, all that. But that's basically what we're presenting. We're saying, hey, we're going to unlock this tier of storage that you already have and make it usable. And you'll see where this is relevant to AI in a minute. If you go to NVIDIA and you buy a server with a bunch of GPUs in it from them, it comes with NVMe drives in it. And you don't have a choice. You're going to get them whether you want them or not. And some of those servers come with 8 NVMe drives. And capacities for NVMe drives are getting bigger. So those drives are getting bigger. And if you buy 100 GPU servers, you can end up with quite a pile of storage. Again, whether you want to or not. You buy GPU servers from other vendors, they may or may not come with storage, but they all have the ability to add NVMe storage devices. So that's this storage here outlined in red. And we found, talking to customers, that typically the storage goes either completely unused or vastly underutilized, which you think is kind of crazy. You paid for it. It's in the server. It's as close to the GPUs as you're going to get. It's right on the PCIe bus. So why aren't people using it? One is because it's another silo. It's another small pool of storage that's a pain to manage, and they just don't want to think about it. The second is that it's not shared unless you do something like share it out with NFS. And then if you've got 50 GPU servers, you've got 50 little NFS shares. Again, what are you going to do with that?
Why did NVIDIA put it there? Do they have a reason for putting it there?
We've asked that question, and it seems sort of nebulous. You know, they talk about use cases like checkpointing and other things.
It might be useful.
That might be useful. And, you know, as a cache or things like that. But here's the reason it's not typically not used also. It's not protected. And it turns out GPU servers go down a lot, either because there's a hardware or software problem, or because in between jobs, it's typical to, you know, wipe them and redeploy them with automation. So anything you store here isn't persistent unless you protect it somehow. So it's this high performance storage, but it's kind of ephemeral, so that limits the use cases.
Seems to me you're saying that the GPU architecture is not what we have designed for managing storage. We just happen to have GPUs around. NVIDIA found a new use for them with AI. But if you're actually starting from scratch, you might design something a lot more sensitive.
Well, you might or you might not. We have customers now who are choosing to put more storage in the GPU servers because they can now use them. So it all depends what side you look at it. So you've got this pool of storage that facts are rarely used. Now, you know, Hammerspace can take any NFS3 volume and bring it in as a storage volume under Hammerspace, make it part of the shared global file system, and then move data around. The other thing that's contributing here, you've got these drives sitting unused. AI context lengths are getting bigger because you get better results when you have more context for queries. Models are getting larger. Things are exceeding the memory capacity of GPU servers. When you exceed the memory capacity, but you have more data to process, what do you have to do? You have to page it out. And today, it usually gets paged out to some external storage that's you purchase for the purpose. It's super fast. It's NVMe. It's on a fast network. But it's still not as fast as this local storage.
But it's not a NVIDIA problem, right? It's the hardware provider problem.
Exactly.
Because they will just put everything in it because it's just a higher price and you can now leverage it. So that's probably much better.
Right. I guess you could put it that way.
NVIDIA likes it.
Yeah. So local storage is always faster than network storage. But network storage is typically used to solve these use cases. Hammerspace puts everything in a big yellow box with some purple arrows. We now incorporate this storage into the global file system, and we can orchestrate data, meaning we can load data into it. We can protect the data that's created there, and we can get data out of it and tier it out to other storage.
So if the GPU needs it, with whatever that's put there in the first place, would the GPU ask Hammerspace to give it some of its own storage back, or which is what sort of should happen, or will the GPU go behind Hammerspace back and just put it in anyway?
Well, the server won't put it behind Hammerspace's back if you've architected it properly. But it can be done. I'll sort of answer what I think is the question behind your question. That data can be moved proactively, and that's typically how it's done in these environments, because this is sort of a batch processing model. Or it could be accessed on demand. If it's accessed on demand, then Hammerspace has to go get it from slower storage and promote it, and that takes time. So typically, this is all going to be done in advance with the batch process. So again, this has some, if you think about this for a little while, you realize there are some cost savings that naturally fall out of this. So we're giving you two things. We're giving you higher performance, and we're saving you money at the same time, which is, I think that's illegal in most places, right? What's the downside? And the downside is you already bought the storage. So you already paid for the storage.
Is there really no downside, or is there a downside on the network side of things? There's no downside at all?
There's a downside if you're the one trying to sell the network storage. But
if you're going to, are you not going to saturate the lines?
Which ones and where, I guess?
It's all 400 gig.
Right.
Probably. So you've got multiple lanes going there, but still. GPUs can take a lot.
That's right.
So building the storage below that, and normally, like you already mentioned, it's NVIDIA within the box, right? So it stays within the box. Now you're going to put it over the network as well. Is that going to
slow things
give some
down?
problems or not?
No. I mean, it could affect, depending on how you're loading the data, how you're moving the data, you may have to upgrade the network back here. But typically what happens with the job is you're loading these NVMe drives with data, you're running some processing, you're offloading some results. Or I'll show you an example where we do a speed comparison with the network where it's a checkpointing job. Checkpointing is the low-hanging fruit here. So let me get to that.
One more question for
Of course.
A global enterprise with United States data center, Munich data center. How do you decide which storage system I use when all users can access it from everywhere?
Right. Yeah. How do you keep files from being stored in Europe, or how do you ensure that files are stored in Europe that shouldn't be stored in the U.S. just for example, right?
But also when you say, okay, performance is bad on this, I need faster performance, that I'm in the same region, because it makes no sense to go on the other side.
Right. And again, I know I keep teasing you with objectives. That is all done with objectives. That's coming next. So tier 0 performance. So think about a checkpointing job. Checkpointing, again, is the low-hanging fruit for tier 0 because it's sort of not real work. It's not what you bought the GPUs for. It's an administrative thing you have to do because if you don't, you can lose progress on your job if a system goes down. So if you look at a checkpoint here, we're looking at a hypothetical checkpoint that's 0.5 terabyte in size. If you write that to the tier 0 local storage, it takes about 4.5 seconds. If you write that over the network, say it's a 100 gig network, it takes 10 times as long. Even if you have a 400 gig network, it takes about 2.5 times longer to write that to the fastest external NVMe. So writing it to tier 0 is saving a lot of time. And then once it's there, and it's out of the critical path, Hammerspace can move that checkpoint to slower storage somewhere and free up that space for the next checkpoint. So this is a really great use case. Remember I told you, you buy NVIDIA GPU servers, they come with storage. The problem's even worse in the cloud. If you rent a GPU server in the cloud, it comes with NVMe drives. They typically don't get used. And your storage alternatives for storing a checkpoint are much, much slower than, say that array you might buy from somebody and have on-prem. So this time savings represented here, it means you spend less time with the GPUs doing administrative things like checkpointing and more time with them actually working. And this can add up to a significant amount of time. It's as if in a year you were able to buy more GPUs. You can get more work done, but with a smaller number. So you can look at that either as increased output or reduced cost. And here's where the cost reduction comes in. Without tier 0, you're probably going to have to buy a high-performance network and a lot of high-performance storage to move that data in and out. With tier 0, you use the storage you have. It's in those GPU servers. You have the existing network. You can use that because it's not in the critical path. You're moving data in and out while the GPU servers are working on local data. And you gain all the data orchestration capabilities that Hammerspace has. So you don't need to buy as much of this tier 1 storage because you can use what you've got, and you probably don't need to buy a new network. And you get more time on the GPUs for real work. So I hesitate to say no downside because nothing in life has no downside, but this seems pretty close. And there's a lot of excitement around it for that reason. And again, I like to throw up some of these names that to show that this stuff really works, and it really works at scale. xAI used this tier 0 architecture with Hammerspace. They had 20 petabytes of NVMe storage in their GPU servers they were not using at all. 20 petabytes. Talk about money thrown away. So we helped them implement that as a tier 0. They were thrilled about the CapEx savings, but they were actually most thrilled about the OpEx because they were, like everybody, out of rack space, out of power, no cooling capacity. And because the system was, the drives were in place already, they didn't have to worry about any of that. So it really does work.
Well, this sounds great, but it just seems so odd to me that they put all that redundant stuff in there with no particular use for it. It seems a very wasteful way of designing.
Yeah, I really don't know the history, but, we found a good use for it. And I just want to quickly go through the mechanics of how this works, and I want to get to the objectives. But, storage comes into Hammerspace and becomes a storage volume. You see storage volumes in the Hammerspace console. In this case, it's an external, NAS system. When you look at a GPU server, we'll take that storage and export it as an NFS share. It becomes a storage volume in Hammerspace. And note that the NFS client and server are there on the same machine. You add more servers, you just have more storage volumes you configure into Hammerspace once, and then we can use those.
For the storage nodes, this is installation of a driver?
No. This is...
oh no, there's already NFS there. Okay,
right.
I forgot.
Yeah, it's okay. Yeah, no drivers, no clients.
Yeah, it's already there.
It's just NFS. It's already there. So that's how you bring those into Hammerspace. It's how you bring any storage in. And then remember how the NFS client and server were running on the same host on the GPU server? We looked at that and we said there's an opportunity there to optimize performance. Because what was happening was the application had to go through the NFS client, which had to go through the whole network stack and the NFS server, only to loop back to the local storage, the local file system, to access the drives. So we contributed an enhancement to NFS so that now an NFS client and server can detect when they're running on the same host, and they skip all this network nonsense in the middle. And applications get virtually direct access to the local file system and the data that way. And again, this is a Linux thing now. It's already in Red Hat. We contributed this.
This is already RFC?
It's not an RFC,
okay.
But it's an enhancement to NFS. It didn't need a new standard because there's nothing here that required it. It's a functionality thing. We use it for tier 0. It's also useful for certain container use cases where you've got one container that's exporting storage locally and you've got other containers that might be running on the same host using that storage. But yeah, that's already in Red Hat since May.
Conflict of interest here in that you're contributing to the NFS design, and you're also making money out of selling enhancements to NFS. I'm misunderstanding the way the systems works, but I'd have thought that, I don't know, Bill, for instance, might be feeling that you've got an advantage over your business that they don't have.
Well, you've confused two things there. It's not, what was the first term you used? Anyway, it was a negative one. Conflict of interest, that was it.
Yes.
It's not a conflict of interest because, the Linux community and the standards bodies they're really serious. There's nothing that they would let us put in here that only benefited us. It has to be something that really benefits the larger community and everybody. So the things we're putting in are enhancements that are legit that anybody can use. Now, is it an advantage to Hammerspace? Well, of course it is. Because if we're creating something, we're the first to know about it, and we'll be the first to use it, and we'll probably use it to a greater extent than anybody else will. Exactly. We're investing in the process because we believe in openness and we want those standards to advance. But heck yeah, we're taking advantage of it to the fullest extent.
That is just, I meet people who move into the open source system and don't really understand the importance of contributing.
Right.
And they see it as being an advantage.
Mm-hmm.
They don't see they have to pay for this by contributing.
That's right. And this is where you'll see companies that create patches, or special kernel versions and, sort of leverage open source, but have their own special piece they keep to the side. And that's a different strategy. We don't do that. Okay, I want to talk a little bit about objectives. I sense I don't have a ton of time left. I'm happy to talk to anybody afterwards as well. Objectives are statements of intent. You're telling Hammerspace the way you want the world to be with regard to your data and storage, at a certain point in time or under certain conditions. For example, 2 examples here. If a file's older than 2 weeks, put it somewhere. Or if a certain metadata tag is set on a file, take an action or disallow an action. Objectives are set up at each Hammerspace site if you have multiple sites or clouds. And this way you can retain local administrative control over them if you need to. But they're also easy to export and import if you need them broadly across all sites. They always apply at the file level. That's their level of granularity, but you can specify them all the way at the share level or bucket or the directory level. So they can happen anywhere in the file system hierarchy. And what objectives do is they let you, based on conditions and very rich things like custom metadata, direct the system to take action. We have a nice GUI that walks through the most common categories of objectives. Those categories are placement, performance, and protection. This is the screen that shows you placement. So you could say, hey, Hammerspace, for files that land in this directory, I want to always make sure they live on this storage volume underneath. Or you might say, hey, Hammerspace, I don't care where you put files that land here, except I don't want them to ever be on this storage. So you can exclude, you can include, you can define multiple instances of the file. You can say, I want to make sure there's always one on NVMe and one in the cloud, for example. And you can have up to 10 instances of files. That's placement.
Great power becomes great responsibility. You can really mess this up if you don't know what you're doing.
On a global scale.
Yes. I would expect Hammerspace, perhaps, to come back and say, you really mean to do this?
Yeah, we do have basic safeguards like that built in, but it is possible to make a mess of things. Typically, we'll often help customers create the first set of objectives based on what their business rules are, what they're trying to do. And then once they get the hang of it, they're off and running.
I once worked with a bank that set the objective that a particular team was so important that they had priority knowledge compiled, which meant the DBA couldn't get its databases changed in time because it was always pushed up by the people who use databases.
Right. Yeah, we can't help bureaucratic problems like that, but yes, we can help data problems. And speaking of performance, the next category is performance. When you bring a storage volume into Hammerspace, we run a quick performance characterization on it. So we know what's the read and write I/O. How many IOPS can it do? What latency is there to get to that storage? And we store that in the database. So that lets you create objectives based on performance. So like the example I used earlier, you can say, hey, on Tuesday, I want this data set to live on storage with this minimum performance standard. Hammerspace, I don't care which storage in specific it is, as long as it meets that performance criteria. And Hammerspace will make sure that that data lives on storage with those characteristics at that time.
So I can tell it to tell me what is the best AI storage I could use for, let's say, training model Claude 4 or something like that.
In a sense, yes. Right. If you know your performance requirements, you can specify them. And obviously you need storage that meets those requirements to back it up. What you don't see over here, there's a column listing all your storage volumes, and as you move these sliders, the list of storage volumes in that column will shrink or grow, showing you the volumes that have that capability. So that prevents you from asking for more than you can deliver. So that's performance objectives. And then protection. You may have detected, I mentioned things like backup and DR, and that Hammerspace can handle snapshots and all those functions. When you add a storage volume to Hammerspace, you specify, or you can optionally specify its durability and its availability characteristics in terms of number of nines. Because honestly, Hammerspace doesn't know if that's a single disk, if it's a RAID 6 set, if it's some fancy erasure-coded thing with 11 billion nines of durability. You have to tell it. Well, once you've told it, then you can create objectives, again, that key off of durability. You can say this data set always needs to be on storage that has this number of nines of durability, or this amount of availability. And of course, you can combine all these things as well.
And how does Hammerspace know the availability of the storage system?
Again, it's because when you add the storage volume into Hammerspace, there are fields where you can specify the number of nines. That's something we can't detect, so you have to tell us. But you tell us once, and then we know.
Then in the very beginning, you had the roadmap, and I read something with local erasure coding. This probably has to do something with this as well?
Actually, yeah, I didn't cover that. So the slide with the Linux NFS enhancements and all that, that also mentioned erasure coding as well. So you may not know, in NFS today, there's a capability for client-side mirroring, and we use that quite a bit. So the NFS client itself can create multiple mirrors of a file. Two of the standards enhancements we're working on now are for client-side striping and erasure coding, so that the NFS client can do the erasure coding and direct the shards to different storage itself. So that's one aspect that's future.
And then you can use very cheap storage because you don't have to do any redundancy in the storage itself.
And it's very scalable because as the number of clients scales, the capability scales. So that's something that's in the future. Currently, we have an erasure coded capability. If you take some of those DSX nodes, for example, and you put block storage on them, we can do erasure coded storage that way, and that becomes a storage volume in Hammerspace.
And the erasure coding will span over DSX nodes?
Correct.
Not inside one node?
Correct.
Okay.
Right, it's spread across nodes. So thanks for bringing that up. That's something I didn't touch on. You know what, I joined the company, I thought, it's a one-product company. How hard can it be? Man, I keep learning more and more every day. And then advanced objectives. So those are the common categories: placement, performance, protection. But you can create objectives with anything you can imagine. Any business rule you could imagine, any workflow automation you can imagine. And we have this little scripting language we call HammerScript that you use to create objectives that are more advanced. And once you understand sort of the library of capabilities, it's pretty intuitive and easy to use. So let me just walk through this top one here. So this one here, is live means this objective is going to take action on live files as opposed to snapshots, because objectives can also be used against snapshots. So if a file is a live file and has the label marketing applied to it, which would be custom metadata, and it has an access age of less than 2 weeks. So it has been accessed within the last 2 weeks. It's a fairly recently accessed file. Then place it on this storage volume. All right? These other similar lines here basically combine with that one to create a tiering approach. Based on the access age of the file, you can make sure it lives different places. So that gives you a little bit of a taste of some of the things you can do. Yes, sir?
So, about protection. A lot of storage companies are implementing some ransomware protection. So they're looking into anomalies with file. Sorry. No.
I can read your mind. I know where you're going, I think.
If you some kind of anomalies sorry, I'm a little bit.
That's okay.
At the moment.
Trust me. I speak a little bit of German.
Okay.
You all speak far better English than I speak German, so no apologies necessary. And I think I understand maybe where you're going. Tell me if I'm right. So with this system, you're asking, do we have any way of sort of preventatively detecting if there's ransomware taking action or doing something, things like that?
Or maybe something more general. There's some objective on monitoring what happened to the file.
I see. Activity level, things like that. Okay.
Example, this file has always been accessed by this user, and now
Right.
Tons of users access this file.
Or for example, every one of the files on this volume suddenly have all been accessed in sequence, and normally that doesn't happen. So you can set up objectives that would key off of actions like that or situations like that. We don't have things designed in a way right now where we'd have a flashing thing in front of the administrator that says ransomware, ransomware. But you could create some capabilities like that.
So could you possibly use your Hammer script language, script language, to detect these? Well, if user X is just doing a lot of file system activity. So could you use your Hammer script language to maybe do a snapshot?
That's an interesting case. I'd have to think about that. It might be possible. It might be possible. We do have lots of information in the system about who is doing what to who and what files are being accessed and all that. And you can access that with Grafana, for example, and break it down as finely as you want and do other things. I would have to think about whether you could do that specifically with an objective.
Okay. And do you also support immutable snapshots with Hammer script?
Yep, you can make snapshots immutable. We do have worm capability, so you can deny the ability to write or delete files and snapshots.
You also support versioning?
Support versioning as well. That's one. If you look back, I went through it kind of quickly, but if you look at one of those architecture slides that shows all the data services, you'll see snapshots, versioning, worm, all those sorts of features.
Do you have API access, so I can integrate it in some Ansible environment?
Yes. Again, thank you for asking something I don't have on the slides. Everything is driven with a REST API, and it's all documented with Swagger. So the documentation is all there. If you want to, you can drive any of these actions programmatically. And our more sophisticated customers, do that. Had a question over here, database gentleman.
When I go with rules-based systems, they start off simple and logical, and they get more and more complex with age. And you really need things like test environments and completeness checking and consistency checking. Otherwise, you find that you build yourself a bottleneck that you didn't realize was there.
Sure.
You have those sort of tools, checks built into your language?
There are some guardrails. If you are entering these rules in the GUI, it will tell you if you don't have a valid expression. It can't predict the future and tell you that you're going to do something really bad to your data by doing that. So there are limits.
It can tell you whether two rules matching consistent.
Well, not two rules. Within one objective, we check for completeness and correctness. You didn't leave out a parenthesis or something. But we don't evaluate them in context of the other objectives and say, hey, you have two that cancel each other out. That's actually valid, and there might be a case you might want to do that. But, so there's a lot of flexibility. Just like with any flexible tool, you can do some damage with it if you aren't careful. But
I'm just very cynical that optimization. You shouldn't do it unless you have to, because almost always it's high risk.
Right, I understand, yeah. Some more examples, right? If you have a file that does not have the keyword scanned, you can block read. Random example. This one's a file name match. And what this does is say, hey, if someone creates a directory named archive, treat it a certain way. In this case, put a copy of those files on object storage. So you can key off patterns, file names, partial file names, things like that. And anything else you can imagine. It's crazy how flexible it is. Back to your question about sort of, you've got all these objectives, things got complicated, how do you keep an eye on it? In the GUI, you can see if your data and storage is in alignment. Alignment means all the objectives have been met. Everything's green, everything's happy. If objectives cannot be met, they'll be yellow or red, and the administrator will be flagged to take some action. You know, for example, if you have conflicting objectives that are irreconcilable, then instruct the system to do two things that can't be done at the same time, you'll see those objectives here with a yellow or a red. Right. Hey, administrator, what do you want me to do? You know, I can't take action. And then, you're right, a system can be very complicated. You've got lots of data moving around, lots of volumes underneath. We try to simplify that with this chord diagram that shows you where data is coming from and going to and why and who's doing it. This is a very simple chord diagram. You see the gray quadrants? These are 4 different storage volumes. Data is flowing from light to dark, and this purple color means that this data is moving because of protection objectives. And it looks like in this case that the objective is probably saying make sure there's always a second copy of data on a different volume, because everything is moving to a second volume there. And these can get very pretty and very crazy looking, but you're able to filter them down by time and by type of data movement, et cetera. So hopefully, once an administrator understands sort of what normal looks like, they can glance over here, and if something looks wildly different, then they know to go dig in and investigate. It's a really clever way versus, you know, looking through logs or something, looking for anomalies. Mm-hmm. Yep. Yes.
Additional metadata is only transparent to the administrator, not to the
additional metadata it's available to anybody who knows how to ask for it. So stuff beyond normal file system data can be queried if you have the command line tools installed on a machine. So you may have a power user that needs to apply metadata or remove metadata or be able to curate in some way. You can give them access to the tools, and then they can do that themselves. And you can do that person by person if you need to. That's right. You could export them and import them into Hammerspace, and that's very common. So speaking of metadata, thank you. I'll breeze through this pretty quickly because I'm almost out of time and you understand the concept. Any sort of business need you may have, you can tag files with metadata. Could be project, customer ID, etc. And then you can have objectives that take action based on those tags. So here you've got files tagged with project 1 and cost center A, and something's going to happen with those. Or, you know, a typical life sciences use case. I have an instrument doing some work on some cells, generating data. It lands somewhere, and then I have to move it. I have to process it. So you can tag those files with the instrument number, any other information you might need. Ah, I love questions like this because they lead into my next slide. If you put tags on a folder, those tags are inherited by any files that land in that folder. So while you do have to set them up somewhere once, you don't have to necessarily set them on every file. Set tags on the folder, files inherit it, and the metadata stays with the file when the file moves. So it'll inherit those tags, and the tags will follow. It's persistent.
And can I also say batch remove tags? I have a directory with the tags, lots of files in there, and then the files are moving not to the same place. So some there, the other ones there. And now I need to remove a certain tag from all these files, but they are not on one location. So I need some mechanism to say, please show me all the files with tag blah 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 and delete this tag.
You can do that. Okay. Yeah. And this is just a shot of the GUI that an administrator could use to set tags. You can also set them on the command line or programmatically. And you can do them in a way that they have a restricted schema. So you have a list, and it's a pick list. And you pick from one of 4 tags. You apply one of 4 tags. You know, from database world, if you have people doing different spellings, and you know, it would be chaos. So you can restrict to a limited schema, or you can have an open approach where you can apply strings of any type.
I mean, logically, this seems to me to be a database. I mean, logically, it's a database. Physically, it's not, but
Right.
yeah.
Yeah, there is definitely database functionality here that drives all this. There are queries going on all the time.
It's a database management facility. Management facility is that.
Yeah, Hammerspace wouldn't be possible without databases, obviously. So there we go. That's inherited metadata. And I'm going to wrap this up really quickly. If you think about an AI workflow, you have a lot of data. You probably don't need all of it, but you need some of it, and you need to figure that out. With assimilation, Hammerspace can help you figure out what you need, leaving the data in place. So you don't have to copy it all to a net new storage system just to figure out what you need. Once you identify the data, you go through that initial process, you get to the high performance piece of the workflow, you can use technology like Tier 0 and like the hyperscale NAS using parallel NFS to do that part of the workflow. It demands high performance. And then you can orchestrate data, of course, from beginning to end here, all the way from that initial data ingest off to archive or whatever happens in that workflow later. Yes, sir.
So, important question for customers. How is Hammerspace licensed?
It's licensed very simply. We say, how much data will you have under management? And we give you a price based on the amount of data. That's it. Doesn't matter how many sites, how many copies, what features you use, it's all inclusive.
But with Hammerspace, there's nothing I don't like about it.
We're working really hard on that. And look, I've been in storage for over a quarter century. I really like it too. It's like nothing else. This is my last slide. Let me just build this out. 4 things to remember. Remember, you can deploy this anywhere. It's software. It runs on open hardware. As long as it runs Linux, you're good. Any storage, block, file, object, cloud, multiple sites, single global namespace. Assimilation means you can bring your information into Hammerspace without going through a lengthy migration. Everything is standards-based. Got this high-performance parallel file system for things that need it. So you no longer need to worry about deploying a Lustre or BGFS or whatever the esoteric thing is. And data orchestration allows you to control where data lives on which stored resources when based on any imaginable criteria. That, ladies and gentlemen, is Hammerspace. Thank you very much for your time.